Now, the boundary value problems, differential equations. What is the boundary value problems? The differential equations so far I discussed are initial value problems. For the differential equation, we know that the state vector at time 0, we know this one. So this one is also often called initial value problems. Or even if we know the vector at time t, we want to find the solution in this interval. It can also be called the special case of initial value problems. However, for boundary value problems, we always know the condition such like this. X for a certain component in the state vector, we know x1, 0. Instead of knowing x2, 0, this one is not known. We know x1, the time of x1 at time t, the variable x1 at time t. We do not know this one, we know this one. And this kind of equation are usually called boundary value problems. How can we solve such a problem? The idea is like this. You can select x2 at 0, and then you can find x1t. And you can find this value. You can select it arbitrarily or randomly, this one, and you can find another value which is of course not equal to the expected one. Then you take the difference between these two and then use a certain algorithm to improve this value, and then find this value again and then try to find the difference. In this way you are improving this value. Finally, you can have you can solve out a value, correct value like this, which gives a final value close to the target value. And this one is also called the shooting method. You have to improve this one again and again until you can find the final target which is close to the given one. And to solve this kind of problem, what we need to do is to know how to use certain functions in Matlab. So let's consider an example, and I will show you through an example, see how we can solve a boundary value problem. Suppose we know this is the original differential equation. And then we know the value y at 0 and at pi over 2. We know these two problems. We do not know the value of y naught at 0. So how can we solve this problem? Again, here we select state variables. If we select state variables, we can easily obtain the standard form of differential equation like this. Let me rewrite it again there. x1 dot equals to x2, x2 dot equals 2 times x1 x2. So this is the standard form of the differential equation itself. how can we describe the boundary conditions? And suppose A equals to 0, B equals to pi over 2. Then the boundary condition, we can write it like this. The first boundary condition is y0 equals to minus 1. In other words, y0 plus 1 equals to 0. And y, we have defined y as x1. So we can interpret this result by x1 a plus 1 equals to 0. This should be the same because y should be x1 and 0 here is denoted by a. Yeah, this is one of them. The other one is x1 b, because y is x1, so minus 1 equals to 0. So this is a boundary condition. We have to rewrite it in this way. And we can use this function to express the original differential equation. And it is the same as the one we used earlier. Given all the commands already. And this is the first command we should use to define the original ordinary differential equation. And this one, I should use it to denote the boundary value equation. And this is the function xa, xb. And here xa1 plus 1, xb1 minus 1, which is the same as the one I denoted there. So this is a boundary condition. If we have original differential equation and the boundary condition, then we can use BVP for boundary value problem, INIT for initialization. We can select certain points for the regions A and B. We can select certain points for the initial state vectors. And then we can use command BVP for 5C to solve the original differential equation boundary value problem. And finally, we should get the results and display it. And this is the final result at 10 by the use of BVP for 5C. So this is the boundary value problems. And also, if the boundary value problems are even more difficult, something like this, you can also write it like this. So if you define A and Xi, you can easily work it out. So you can solve the problem again. And also, if you have extra variables here, for instance, if alpha and beta are null, then we need 2 points to determine the shape of the responses. However, if alpha and beta are not given, then we need 4 initial points, given points, to determine the differential equation solution and the value of alpha and beta. So in this way, we can also use boundary value problem solver to solve the problem. So I think we have to stop today here. Any questions? Too much mathematics, I think. So if you have any questions, just ask me, or later you can contact me through email. Too much, I think.